energy efficiency, connected devices, security, and health. These are the market megatrends that will focus the world's attention for years to come. They are the engines of progress that drive technology ever faster in a smarter world. The relentless flow of data and information in this smarter world faces the constant threat of corruption or misuse, both accidental and intentional, which is why this smarter world, more than ever, requires more secure connections than ever before. This is the driving force behind NXP. Our businesses develop, produce, and provide secure connections in automotive, identification, infrastructure and industrial, portable and computing, and standard products. Our mission, to meet the megatrends with secure connections for a smarter world.
So, ladies and gentlemen, please join me in welcoming Mr. Andrew Russell, NXP Semiconductors.
Good afternoon. It's wonderful to be here again. I think this is the third time I'm speaking at this event, and to share some thoughts with you about the connected consumer and smart cities, and to share with you NXP's vision of the Internet of Things. So, how do we see the Internet of Things developing as we move forward? I think along with the smartphone and cloud services and cloud computing, they are revolutionizing the way we interact socially and with the physical things around us. IoT, in our view, will have a profound impact and role in shaping cities and their occupants' lives as we move forward. And we think that if you fast forward and look back, the IoT revolution will come to be known as the second industrial revolution. And there's no doubt that the impact on everyday lives is already being felt and is going to be greater as we move forward. So let's look at cities and why this discussion and why these comments about smart cities. Why do people talk about that? And why do we need smart cities? Why do cities need to be instrumented, analyzed, and controlled? Well, cities cover just 2% of the Earth's surface, but house half the world's population. So 3.5 or 3.8 billion people live in cities today. They consume 3/4 of the global energy, and they're responsible for 80% of global emissions. And if you look closer to Taipei, to China, in fact, around about 35 million people a year are moving from the countryside into cities. So that if you look between 2010 and 2030, around 350 million people will move from the countryside in China into the cities. So this makes it the largest migration of humans in history. And it's happening right now in the next 2 decades. So there's no doubt that we're undergoing some massive changes in the 21st century due to urbanization. And if you look at some of the comments I passed earlier on this slide, you can see why building smart cities, instrumenting them, analyzing them, and providing controls and feedback mechanisms are critically important if we're to reduce the impact of cities on the environment and to make people's lives more comfortable and easier. So let's look quickly now at urbanization across the developing world. It's driving new challenges, as I mentioned on the previous slide. By 2030 in China, there will be 1 billion city dwellers who, over and above the 2010 figures, will require an extra 40 billion square meters of living, shopping, industrial space, public space. 40 billion square meters is an area about the size of Switzerland, or it's an area about the size of 10 New Yorks. So that's just one country, that's China. And this scenario is being played out across many parts of Asia and many parts of the developing world. If you look at China specifically, and you look at urbanization between now and 2030, in 2030 there'll be over 220 cities with more than 1 million inhabitants in China alone. 400 additional million city dwellers. That's more than the population of the US moving from the countryside into the cities in the next 2 decades. So with these 2 slides, what I want to do is paint a picture as to the size and the impact of the changes that are taking place as countries urbanize, as we go through a huge urbanization cycle in the 21st century. And it doesn't just apply to China, it applies across much of the developing world. So let's just talk a bit about some of the examples of smart city solutions developed by NXP. We're involved in many, many things: transport and traffic, shopping, smart home, e-government. We're the biggest shipper of secure elements for passports, smart infrastructure, smart grid, and of course, smart building. And all of these things enable us to work more efficiently, enable us to reduce waste and make people's lives easier and simpler. So if you look just for one example at smart home, down the bottom left-hand corner there, we're very involved in the smart lighting space, and we'll talk a bit about that later on. We're the biggest player in NFC globally, so we ship billions of NFC units every year, and they go into all sorts of applications. Energy harvesting devices, we've got some really exciting reference designs, and we have products in production that actually harvest the energy from the action of pressing a switch. That then enables a very low power transceiver which sends a message to a gateway which controls some lights or an appliance. No batteries required, no wires required at all. So that's just as an example of the kind of technologies that we can bring to bear on some of these applications. And of course, smart appliances. I think some of the previous speakers spoke about that. We'll talk a bit about that a little bit later on. And then finally, energy monitoring. And of course, if you look at things like transport and traffic, we're a very big player in the automotive markets, very involved in intelligent traffic management, road tolling systems, telematics. Again, information from these kind of applications ends up in the cloud, it gets analyzed, and we use that to provide improved services and improved driving conditions. Same thing with public transport as well. We're able to provide some very unique solutions in that space. And then finally on shopping, a lot of you will have noticed your credit cards now have a smart element in them, NFC, e-secure element to make shopping easier and a great experience for the user. Let's talk about building blocks for a smarter world, and I think some of the previous speakers may have touched on this already, but let's just talk about what are the four things that will go towards making a smarter world and smarter cities. And if you look on the left-hand side there, you see the first thing we talk about is connected sensors. And one of the things that's happened in the last 4 or 5 years with the mobile phones is the cost of sensors has plummeted because of the volumes demanded by a mobile phone. A high-end Samsung phone may have as many as 20 sensors on it. Coupled to that, you have low-cost 32-bit microprocessing power. I'm talking about very, very low power here, milliamps in the active mode, with peripherals. And of course, embedded on that, a transceiver. And if you look at NXP's JN5168, it's an 802.15.4 compliant transceiver with a 32-bit MCU integrated onto the same piece of silicon. And those, of course, are coupled to sensors and actuators. And of course, let's not forget GPS as well, so you know where something is. Very important. The second part of the building block is the networks. We have a lot of discussion about networks today. There are many, many network standards. If you start right at the top with LT and 3G, you go through WiMAX, and then you get, of course, to low power networks that are typically used in automation, home automation, building automation, things like Zigbee, NXP's Genet IP, which is a 6 low-pan standard, BLE, hugely important standard, NFC, Z-Wave, so on and so forth. And then, of course, wired standards like Ethernet, and so on and so forth. And what's important here is that no single standard is going to dominate. In the home, you will not have one standard. You will have quite a few different standards. You will have Bluetooth. You will have Zigbee. You will have 6 low-pan. Because some of the end applications that we deal with fit better with different network standards. And those network standards will come together in the gateway. And what happens when something gets into the gateway? It gets up into the cloud. And that's actually where we want the data. We want it in the cloud, because once it's in the cloud, we can do something with it. We can manipulate it. We can build compound applications. And a compound application is an application where you take data from one application area and you combine it with a different application area to create a new application. We heard about parking in China and in San Francisco a while ago. There are applications running now where they couple that, looking for a parking spot and how long you're going to spend on the parking spot with, for example, a service, car service or oil change. So So these are the kind of things that you will see take place as we move forward. And that's the power of the internet. It's the ability to get data into the cloud and to build these compound applications. And once you do that, you can start to generate new business models and new revenue streams. And I really believe that the cloud is fundamentally going to drive IoT adoption. That's the big driver. It's getting data into the cloud and being able to do something with it to drive these new business models. And of course, the final piece of the puzzle is the mobile computing platform, either a mobile phone or tablet. And that's the fundamental way that people will interact with IoT and with the cloud. It will be with a mobile phone or a tablet. So let's look, I said the cloud's going to play a fundamental role in driving IoT proliferation. If you go back to 2000, on the bottom left-hand corner there, you've had basic IoT RX TX modules, typically NFC. It was just the start of the IoT revolution. You then had IoT-enabled application boards and products and things developed a little from there. You then got to the launch of the smartphone, 2008, 2009. And worldwide IoT connectivity, you get apps on Android, iOS, Linux, and so forth. And we're really at this stage now, stage number 4, which is the cloud-based applications. They're starting to emerge. You hear about iCloud. Apple made an announcement a few days ago opening up their platform so that people can build applications on their phone, which I think is a very, very exciting development. And then, of course, if you look at where this will end up, stage number 5, you'll have these big compound applications that really link all sorts of application areas across a region or a city and build these fantastic compound applications and build these new revenue streams and new models. And there's what you've seen in the last few years is a big increase in the number of companies offering cloud services. So there's a few there. You see the Greenwave Systems who are a partner with us. We have Isla, we have ArrayNet. There's lots of them that are emerging now that are able to connect these IoT devices together and get the data up into the cloud. So some data points. This is some data from Wired, and it's by a gentleman called Derek Corter, just to give you some indication of how quickly things are developing. As of May 2014, they estimated there were 12.5 billion things connected to the web, IoT nodes. If you look at projections for 2020, by 2020, they're saying each individual will have up to 10 IoT nodes. They'll own up to 10 IoT nodes. If you look at the bottom right-hand corner, the projection by 2022 is that every home will own at least 50 IoT things, IoT nodes in the home. I've seen higher estimates than that. If you think about lighting, smart lighting, the area that we're really involved in with LightPro, the potential we think is even bigger than that. And if you look at the economic value that's projected from connected devices by 2020, people are talking about a figure of $1.9 trillion. If you look at the World Bank and the GE study that was done a few years ago, they say that by 2030, up to half the value of the global economy will be impacted by IoT. They talk about $30 or $32 trillion. So $32 trillion of value will be impacted, improved, or made more efficient or made better by the application of IoT technology. And that's GE and the World Bank. So if you look, continuing, you look at some of the applications that are being applied. You look at bridges in the US, 11% of all bridges are structurally deficient. What are they doing? They're busy putting sensors onto bridges and they're monitoring them. So one of the big things that's going to change with IoT is that you will see a shift from in maintenance practices. So preventive maintenance will move to maintenance on demand because you have a piece of equipment or a building, you have it instrumented, you're analyzing it, you're monitoring it continuously. You know when you need to do something because the data is telling you, I need to look at it and I need to work on it. You hear the same thing about jet engines as well. That's also moving, that kind of technology is moving towards maintenance on demand rather than just straight preventative maintenance. Let's look at the smart home. There were a few slides like this shown earlier on. So if you look at typically what you'll see in a smart home, you'll see energy, green energy in the top left-hand corner, so typically things like wind, solar. Inside the home, you'll see appliances, smart connected appliances, sensors, lights, heating, cooling, smoke detectors, things like that, all connected in a network, typically Zigbee or Genet IP. If you look at health on the bottom, and we'll talk a little bit about that further on the bottom row, we'll be able to monitor our health. That typically will use a low power body area network coupled to Bluetooth, which will be on the phone, and that will go up into the cloud for new care models. And I'll mention a bit about that a bit further on. And then, of course, you'll have Zigbee doing all the energy measurement and smart energy monitoring, things like that. And everything comes together in the gateway. And I think a lot of change will have to take place in the gateway moving forward. Gateways are going to have to be more than just Wi-Fi and Zigbee. They'll have to be Wi-Fi, Zigbee, 6-LoWPAN, BLE, perhaps even NFC. So multi-standard gateways are something that the industry has to bring to market. So some examples of NXP technology in IoT used in smart home applications and smart city applications. Here's a very, very high performance camera that can be connected to the internet to provide video streaming services for a security model. So typically here you would buy a service that would loop in 24 hours or 7 days or a month, and you'd pay based on how big you wanted the loop. But this is very, very low power. Battery backup, it has Wi-Fi connectivity, so there's no cables involved other than the power cable. Outstanding best-in-class low-light performance, so this camera can see color at 0.5 lux. There's no need for infrared illumination, which is important. It's got software tilt and pan, extremely small and compact, and of course the SoC that's controlling this camera and the IoT connectivity is done by NXP products. So if you look at white goods evolution, NXP has been a big player in white goods for many years, where we've supplied devices for controlling motors, drivers, MCUs, displays, touch panels, so on and so forth. And what you see now with some of the newer appliances that are coming out, you've got NFC on those. So NFC has the ability to make the consumer's interaction with technology a very, very pleasant experience. And typically what you do with a product like this is you would tap the appliance with your mobile phone, the app would automatically load, and then you could control your appliance. You could have many more different settings for washing, for example. Because it's connected to the internet, you can also change it or start it or stop it remotely. So if you're out and about, you're able to do that. So these are some of the benefits that this kind of technology will bring. This, of course, another example of how this can work with a compound application is that this device would be linked to the energy profile, energy cost profile for the local energy provider, and your machine would then only run when the electricity charges were the lowest. And typically that would be between 12 at night and, say, 5 a.m. in the morning. And that's an example of how you can apply this technology to lower the costs of appliances, the energy costs, and of course reduce the load on the system, or balance the load out on the energy system. So lighting, so in February this year we launched Light Pro in Shenzhen. We had about 500 people come and join us there, and we spoke about the smart lighting revolution. We think this is a huge application for IoT. If you take an average office building, if you convert from incandescent to LED, you get around about a 70% saving on energy. And if you then take that to smart light, you get a further 30% cost reduction off of that again as well. So the payback time for equipping a building with a smart lighting system is about 2 years. And you can really affect some very good energy saving strategies to do that. But typically what a lamp like this will have, it'll have an NXP SSL driver in there, a solid state lamp driver chip. We're the biggest supplier of lighting driver chips globally. And to that we couple a JN5168 802.15.4 transceiver with a 32-bit MCU in there, and that then becomes a networked lamp. And that talks on a 6-LoWPAN network. We can have up to 500 of these lamps in a network. That's controlled by a gateway. You set that up using a PC, and in the local offices you can use your mobile phone or your tablet to control the lights. And again, using NFC, you simply tap the NFC icon and the app will automatically load onto your phone. You can control it. So an example here of NXP intelligent street lighting using IoT and using JN5168 32-bit MCU technology. So this is a system we worked with a partner in the Netherlands to install, up to 80% energy saving, 50% lower energy costs. Again, maintenance on demand. Of course, reduced CO2 emissions and much reduced light pollution. So the lights, for example, only come on when someone's in the vicinity. There's some of the technology that's being applied to reduce light pollution, reduce energy costs. If you look at the system, the features were dynamic lighting, weather controlled, so it looks at the ambient lighting environment, adjusts the lighting accordingly. Cloud-based control software, so you get reports on a regular basis as to how the system is performing. If a light goes down, one of the lamps goes down, it reports via an email to a central workstation to say that I've got a problem, I need to be maintained or repaired. And of course, the system can also be controlled via SMS. And because it uses a self-healing tree network, it's extremely robust, and you can build very, very long chains of lamps, so many kilometers long, using this low-power 802.15.4 networking standard, 6 low-power networking standard. So LightPro, I mentioned a bit earlier on that we launched in Shenzhen earlier this year. So this is an open professional lighting platform which runs on the Genet IPv6 low-pan stack or Zigbee. It will also run on the Zigbee if that's what the customer wants. It can support up to 500 nodes per gateway. So typically an office floor is about 500 nodes. So one gateway, $100 gateway will look after a whole office floor of these smart lights. And of course you can then interface sensors into that to detect ambient light levels. If you have lamps next to the window and it's bright outside, it'll shut those lamps down. It'll control the lamps in terms of timing. Usage, for example, if you go in to do a presentation, it detects that automatically, changes the lights accordingly. And typically the user interface is via an Android app or via energy harvesting switches. So let's talk a little bit about healthcare, because this is another area that IoT is going to revolutionize. And I spoke about this a few weeks ago at a Titra event here, Smart City event. And I think the basic message for healthcare is we're really headed for trouble. And there's two major things that are happening. One is that you've got an aging population. Even in China, the population is aging very quickly. The second point is that you've got lots of people with chronic disease, long-term disease. If you look at the figures here, and they're for the United States, 24% of people in the US have a chronic disease, have a chronic long-term disease. If you look on the right-hand side, prevalence of chronic disease in the US total, half the population has some chronic disease. And that situation is mirrored in all across the developed world. And China is not far behind either. If you look at medication, bottom left-hand corner, a big problem in the US, of course, is that people, and we see this elsewhere as well, don't complete their courses of antibiotics. So you're getting these bug-resistant diseases or bacteria emerging. That's really a big medical problem. And of course, if you look at the healthcare costs, you can see here that they're running at 4 times the rate of inflation. And that's data from bottom left-hand corner there from 1999. So healthcare costs are spiraling, and they're out of control. So what will happen as we move forward, of course, is that there'll be new trends and technologies applied to deal with this problem. So we'll move from therapy to prevention. We'll move from hospital to point of care, and I'll talk a little bit about that shortly. Increased therapy effectiveness will be focused on, and increased efficiency of the delivered services. So if you look on the left-hand corner there, NXP is working on very, very low-power body area networks, and there you have sensors implanted in the individual's body. They talk through this ultra-low power body area network, typically to a Bluetooth device like a mobile phone or a dongle that you hang around your neck. And that then goes up into the cloud, so the medical profession has got a record of how your body's performing. If you've got a chronic disease, they can monitor that. One example, of course, is if you look at diabetes, we're able to monitor and track that live right now with some of the technology that we have. In terms of therapy effectiveness, using NFC technologies, we can track and make sure that people are taking their medication and they finish the course, which is very important if we're to prevent these drug-resistant bugs from emerging. And of course, on the right-hand side there, you see using Bluetooth, and some of the speakers touched on this earlier on, wearables, and that's a booming market, and that's part of the health and fitness market. On the left-hand side, of course, is the medical and the care market. So just to summarize, NXP and the Smart City Challenge, I think cities and rapid urbanization pose some of the biggest technological and economic challenges that we face. Huge, huge challenges for the 21st century. Instrumented, quantified, and automated systems utilizing IoT resources hold the potential to save billions of dollars and to make the lives of city dwellers much better, without a doubt. New applications are going to be synthesized in the cloud that will leverage IoT resources across many different applications to create these new compound applications that will allow new business models and new revenue streams to be developed. And finally, NXP provides key hardware and software, we're also a software company, technologies and product solutions for smart cities. IoT end nodes, we're really a specialist in that area, ultra-low power IoT end nodes. Infrastructure for automotive telematics, big player in that market. Home automation systems, so set-top boxes, lighting systems, appliances, medical well-being, transportation, and of course, as I mentioned earlier on, we're the biggest supplier globally on NFC and secure element technology. Thank you very much. Thank you.